This computer.
There you go. Hey, welcome to Coffee Compiler Club. We're here today to talk about everything to do with compilers and language runtimes and garbage collections and type systems and whether or not error messages suck from every kind of error message on the planet. How do you error message a missing close quote? Everyone has a different opinion. Anyhow, you're all being recorded live. You'll show up on YouTube videos within, who knows, hours or days. I'm obviously recording remote. I'm at my daughter-in-law's stepdaughter's house with my grandchild, who may come over and pay us a visit in the middle of the meeting. So just be prepared. And that's all my opening spiel. Everyone's heard it before. Most people have. And we can carry on with the conversation that was running in Discord about whether or not you should use color and how do you handle in error messages and how do you handle like a missing open close quote. And actually there's a Google Docs and there are some good examples in Discord, and I don't care if somebody wants to carry on the conversation. I'm attempting to find, oh, it's the announcements section here. Oh God, okay. I'm sorting out our messages. And I'll move some into Docs. Yes, here's a good set right here. Just as whatever. There's somebody's already, that's probably Alan. Thank you, Alan. I'm cutting and pasting and I'm going to like deal. Somebody else want to say something about error messages, or we don't care? Language server. What was the language server question here? Is this, and what is Google Docs doing? Fine. Oh shit. Pardon my French.
I am using color in my error messages.
How, since when?
Since forever ago.
Oh, nice. Okay.
Yeah, I think color is not really controversial. I mean, if it supports
Okay.
it, you do color. That's the end of the story.
Yeah. I don't know how to throw color into Google Docs on error messages, or even what makes sense. I threw out 2 different copies of error message in the Google Docs, which, you know, Alan, Cameron has to do sharing if anyone cares.
The one thing that kind of bothers me is terminals don't seem to have a night and a dark and light mode or theme. So I feel like if you can say like reddish for like disregard what kind of like light or dark, just be like a red appropriate for whatever theme you're using, that would be really helpful because the colors seem to be like hard coded to RGB, and it would be nice if like you can just say this is going to be reddish and that's going to be like
Well,
bolded
there's strings which will convert to a number, which is RGB, and that everyone on the planet supports. But you want like a theme that is contrasting. If I change my color scheme on my X term from light to dark,
yeah.
you know, all the
So
colors to map.
I had a couple of colors to mean a few different things, but this is for debugging. It's not for actual error messages. Error messages, I just pick red because it works for regardless of what color you use. But my other stuff like code coverage, that's not so friendly to read.
You could syntax color the line that you dumped out, followed by red for your error and your quoted piece of, or underlined piece of whatever that was going to be, you know, barked on. No one cares. This conversation. There's Ganesh. We're gonna. How did we get here anyhow? Ganesh, your email and your name don't match. You always take forever to find. There you go. Okay, too quiet. Come on.
All right, so you had told me to
What
defer
else?
on asking Lynn a question, so you want to go ahead?
Oh yeah, no, Lynn. Sorry. Yeah.
Okay.
Yeah. Who are you and what are you doing?
Okay. Actually, this is the second time I joined the meeting. I am Lin. You can also call me David. I actually recently working on the blockchain technology and focusing on the smart contract executing engine. And we are trying to see whether it is possible, you know, to speed up the executions performance. Right. And also last time I mentioned that we are investigating, you know, the JIT or the AOT But recently we actually think maybe we can just start from the performance profiling, which means we were trying to see whether there is any optimizations can be done in the interpreter, because the most of the virtual machine on blockchain is just an interpreter, and they run the bytecode one by one, and usually there is just a big loop and a switch case implementation. So we were trying to see whether it is possible to have a jump table and to use that a threaded jump instead of the loop switch, and to see whether we can get the speed up. And also we were trying to figure out whether there can be some pattern used in the use case. For example, in the blockchain, usually there is a smart contract that just do money transfer, right, from one account to another. So this is quite a similar pattern to almost all the smart contracts. And so in the bytecode level, we will try to see whether we can combine those bytecodes that implement this function together. And so we don't have to to jump from one bytecode to another, but we just fuse them together to make maybe a combined or a huge OP code or bytecode, and then we save the jump and save the stack operations. So yeah, that's our thinking. Yeah, our idea.
So a couple things. If you make your bytecodes get more and more complicated, you have to support them for all time. So don't publish as a standard things that you do to bytecodes beyond what you really want to support forever. Like maybe you do want to support moving money from column A to column B forever. But if you want to stack several such things together, don't publish it as a standard. You have an implementation that does an optimization, which replaces one bytecode with a magic internal only special bytecode that does something else. Another thing you can do is in the bytecode interpreter, when he's done with the current bytecode, if it's one of these first bytecodes of a sequence that you suspect is common, instead of just going to the general dispatch loop, you can pull the next bytecode up and determine that it also is the next one that you would expect in a sequence, and then have an inlined. So instead of having a general interpreter jump, you have a highly predictable static branch and an x86. It'll run somewhat faster. It's substantially faster, and then just run the next bytecode in a row. But once you get beyond much more complexity than that, like replacing first look at bytecodes with a validated look at bytecodes by changing the bytecode format, stacking several together where there's a common sequence. Once you get past that, you're better off flipping to some sort of JIT.
Yeah. We were thinking of maybe we first have something like a bytecode verifier or something operator, which means we load the bytecode first and then do the parsing based on our profile result, so we know which pattern of the bytecode we know is a heavy or a common, and then we try to
Well,
okay.
When you load bytecodes, you are almost going to surely be some sort of IO bound, which means do any static analysis like verification while you're loading, because you're going to be waiting on disk anyhow. Make sure you overlap the IO with getting the bytecodes in, but just verify while you're doing it. Then if you're going to start doing optimizations, if you're doing one shot init, if it's not complicated, you could do that while you're loading it as well. If you're doing things that are like, this is more optimal and we expect this to be common, you might let that actually become common. It kind of varies. Now you're getting into the realm of maybe it helps and maybe it doesn't. So a lot of bytecodes that Java has are run never or run once, and anything you do on a run once bytecode past the bare minimum, total waste of time. And I don't know if that's true in the blockchain.
Okay. Yes. So for the Web3 work, blockchain work, we also recently trying to investigate the WebAssembly, and it's kind of popular in the field of blockchain. And also, we think they choose WebAssembly for the multi-language support. And but by using multi-language support, you need to have GC for high level or managed runtime language. So I also have some ideas of the how to introducing GC to WebAssembly runtime. But I'm just
There's a bunch of prior work on people talking about GC and WebAssembly.
Yes. So yes, I'm also working in maybe open source project that trying to see whether we can introduce a WebAssembly a GC to the WebAssembly to a WebAssembly virtual machine. But it's a kind of complicated. The general idea I have is that if I introduce GC to WebAssembly, it is much more like that. I introduce a very complicated component into the VM, the virtual machine, which makes me think that it is much more like you turn the WebAssembly into the Java or the JVM. Because recently I think people choose WebAssembly because it's lightweight and because it's easy to be implemented. But if we introduce much complicated components there, how can we make sure that it will not be turn into another JVM or
Generally speaking,
You have JavaScript in there, right? So if you wanted to use some GC thingy, you can just
Use JavaScript. Yeah.
and well, the other thing is that you end up often writing the GC in not in WebAssembly itself, but you can write a GC and compile it to WebAssembly. So the problem is there isn't GC has to map closely to the language design itself that you're compiling to WebAssembly, and that's where the problems come, unless you're doing a conservative collector.
I mean, even the WebAssembly people themselves haven't figured out how they exactly want to do things. So I think trying to invent a GC as a third party is like a tall order there.
I agree with Simon.
Threw the link into the doc and into the chat. So there's an effort to do that, and I'm with these guys. Maybe
I'm
it's
surprised
not a good
that's
plan
not
for
built
you to
in.
try it. No, it's not, for the good reason that it complicates the model a lot. So if WebAssembly is intended to be highly portable and you demand a GC in your highly portable thing, you're not highly portable anymore.
I always thought it was meant only for the web. And every time I look at it, you have to use some web specifics to like do anything with it.
I think their high level goal is not to be tied to the web per se, but
I mean,
the name is WebAssembly. So
I mean, there are groups focused on the web part, and there are groups focused on basically running it everywhere. I try to invite a person from that effort for one of our next meetings, so hopefully that works out. But I mean, it's a lot of action at a spooky distance if you're trying to have a GC while trying to retain the flexibility of saying you can compile any language to WebAssembly, and including languages with generics without forcing a specific route how generics are implemented, and that complicates things a lot.
Embedded objects, if you allow one object to be inline directly in another, like you get out of C#, C++, that screws with your GC choices. You have to track the GC pointers, and you have to tell people this is a GC pointer. If you're compiling the loops into arrays and you want to have the array offset math done by your compiler, then you have to tell the GC this is a derived pointer. It's pointing in the middle of an array. Here's the base of the array. That there's some sort of life got a lot more complicated. Right.
Yes. Actually, last year I have made some slides that introducing my thinking of just implement just how the GC will be for WebAssembly, but I think it's very complicated. And you know, I think that there is actually two kind of solutions for me. One is that, you know, if you want to support multi-language supporting, you just compile the whole virtual machine to WebAssembly. Then we know that we leverage the GC algorithm. For example, if I can compile the Java virtual machine or the OpenGDK into the WebAssembly, so I don't care about how GC works, right? I can announce that Java can be run smoothly on WebAssembly, but that, you know, introduce the burden.
You're compiling.
I mean,
I heard two
Yeah.
different things. You're compiling
Yeah.
Java into WebAssembly, which I know there are projects doing that.
Yeah.
Are you
No,
compiling the JVM to WebAssembly, which I'll claim that WebAssembly lacks key things that the JVM relies on that I don't think you're just going to get that way.
Can
Yeah,
you
yeah,
even
yeah.
install
Actually-
new code in the WebAssembly?
Well, I actually I just shared the link. It's just my draft idea. So there is actually two ways. The first one is that to announce that I can support multi-language on WebAssembly. The first one is that I have the whole virtual machine compiled, which, you know, a project called TinyGo, they just do these things. They have a simplicated Go language runtime. It's not the full version, but they can compile to WebAssembly totally. So they announced that, you know, you can have your Go language running with WebAssembly. And then another one is that, as Cliff mentioned, we need to do much work in WebAssembly runtime. And then we have GC, and then maybe we have a front-end compiler that compile different language to the WebAssembly. Then we have the WebAssembly bytecode running on the WebAssembly virtual machine. So that means we have a lot of work, you know, introduced into the WebAssembly runtime.
Right. I mean, there's people with the WebAssembly group trying to do that, and there's outstanding proposals on it, and you would be another effort as opposed to piling in on the existing effort. That's I guess the
I mean the core point people are making for the second approach is that most browsers already have a high quality garbage collector, and that garbage collector already needs to have a basic understanding of bridging languages, because in most parts you have code written in JavaScript and browser helpers or browser intrinsics or browser infrastructure written in C++. And in most browser implementations, the GSC already needs to understand this gap between JavaScript and C++. So saying, well, let's just try getting it generic enough to support all the languages is certainly, I think, a valid point there, even if it's probably a mountain of work.
About to say it's a mountain of work. The job to get Hotspot to do Java GC and C++, which was the implementing the whole thing, GC, that was a mountain of work and a huge, endless tract of bugs.
Yeah.
Like getting stability of that took years upon years.
Yeah, I mean, you don't have like this one-to-one relationship between JavaScript and C++, but you have like an M2N relationship where you can have arbitrary languages compiling to WebAssembly, wanting to garbage collect each other's stuff in the worst case.
But I think it will not save the problems that Cliff showed earlier or mentioned earlier, right? Different languages have different ways of how objects work. So your GC roots will be different. The JavaScript garbage collector probably will not help you with that.
Well, I mean, it will have to be extended to understand it. I mean, there's
no. There's no extension here. If you change the core requirements of what an object is, you have to throw away the garbage collector and redo. It is not the same thing as an extension. It's this no longer works. This entire strategy no longer works.
Yeah, then let's not call it extension, but like migrating it. But in the end, I have a look at proposals and the discussions of how to represent generic types. I think everything that's happening in that proposal has already to deal with how to garbage collect the things afterward.
Yeah, there are
So-
3 really easy things to add to a language: garbage collection, security, and scalability. So all you
Yes.
need is a library for each. You just drop them in, and poof, you got
You
everything.
forgot serialization.
Like for
yes.
threads, right?
Oh, yes.
Oh, I haven't bumped
Jeez.
into that problem yet.
Oh yeah.
Yeah.
Well, we can steer you that way before long.
I do think it's possible to abstract out garbage
concurrency,
collection as a
Matt, yeah.
library, but it's going to suck from a performance point of view, just because of
No, it's not. It's not. Yes, it sucks, but that's not the issue. The issue is it just cuts out certain features. You cannot have object inlining unless you've defined it in the garbage collector from the scratch, and that immediately turns around and denies many other things, or else your performance sucks hugely.
you support object inlining by having a callback on every pointer. That's the point. You could do it,
Yes,
but it's going to
with
suck.
huge. It's gonna
Yeah.
huge performance hits.
I
Like
think
numbers
the
that would be ludicrous.
I think the WebAssembly or browser people are basically trying to reach a state of having something that works. And my assumption is that they believe that all the performance problems can basically be solved with like with the combined budget of Apple and Google and Amazon and Microsoft. So that doesn't matter too much.
Well, that is a nice
Have any of
combined
you
budget.
used WebAssembly?
Yeah, but the one who's used it the most here is what's his name? He's not here this week. He's currently using WebAssembly with Crane Lift as his back end.
Uh-huh.
Not Max.
No, it's so embarrassing that I forget names this easily.
Right.
No, I think I know who you're talking
Yeah.
about. It's the one that disagreed with C being
Yes.
between generating
Oh.
C code.
Undefined behavior, which I'm with you, Levo. I've left. with
Yeah,
that all my
you're the
life.
only
It's fine.
one.
Fine.
I looked into the WebAssembly specs because people kept on like asking me if I'm going to support WebAssembly. I remember liking WebAssembly like the first time I heard it in I think 2016, even though the Wikipedia says 17. I'm pretty sure it's 16. Anyway,
You're right.
after like a first year or two, when I like learned more about it, I'm like, this is I just did not like WebAssembly after that, and it actually blows my mind that people continues to like it because their goals don't match up with their other goals. It's like I remember a guy what is actually I'm not gonna
Isn't that a normal
misquote
thing in the
him,
browser
but
space?
yeah, it's just a mess. Like it's not coherent.
Mm-hmm.
So
I mean, isn't
WebAssembly,
that
when it started, it was pretty simple, and it was basically
Yeah.
it grew out of this project where it was first done in JavaScript, and basically it had a header that said, "I'm not doing any of the bad stuff. Trust me."
I remember
And-
that. Yeah, I remember reading that.
And so basically each JavaScript, so the contract was, I'm going to put this at the top of the JavaScript file. Then all the things that I write in JavaScript won't do any of the following. No evals, no this, no that, no the other thing. And as long as I follow all those, it's a hint to the compiler that it doesn't have to suck. And then they eventually made a binary, an IR for it and stuff like that. And it grew out of that, but it's, it continues to grow.
I do remember that initial header saying, I'm writing only perfectly sane things that you can optimize the crap out of because I'm not cheating in any way. Yeah.
Slightly unrelated, I decided to actually plug in the Ethernet cable this time. Hopefully the sound is better. But
it's
yeah,
better?
I was looking at the.
Did you turn it on?
No, usually I'm on Wi-Fi, so I decided to actually use the cable for once. But I was talking about the memset implementation last time about using the zero cache line. I could never make it work on my laptop, but there's a what is it? So in Japan, they have a new supercomputer. I mean, it's new as of a few years ago, but they made their own custom chip to go in that supercomputer. And in that hardware manual, there's a section on zero cache line, and it works exactly how I want it to work. So it allocates the cache it allocates the cache line 0 into the L2 cache without reading from memory, and then you can overwrite that, and then you avoid the read. So that's one.
I'm putting the link into the doc.
I'm pretty sure that WebAssembly has no support for relock, so I don't know about the performance about it.
Oh, yeah.
Well,
Yeah, I
WebAssembly,
think that's okay.
WebAssembly is more like the old DOS
Looked in the
model.
code, I thought it was going to be a mess, but so I just like put a few lines and it just magically worked.
When Intel released the original 8080, the format they used, so your first 4 bytes of the file basically said how much memory do you want, and every assembler ever always put all of it. I think FFFF or whatever, like, or 8000. I can't remember now, but I think it was 2 bytes. It might have been. But basically, you ask for every single bit of memory, and so that's kind of how WebAssembly works, right? Like, how much memory do you want? You know, and it's like that's your memory space. So it's kind of a fixed size.
When you have 10 megabytes and you want to grow it, I don't feel like doing a memory copy.
No, okay, so separate things here. So Cameron's thing, Java has for many years said if you don't supply GC args, the default heap is 1/4 of what the OS claims the system memory is, which is sort of a reasonably easy compromise. It doesn't take it all, but it takes a big chunk that scales. And then for Levo, you know, you don't want to mem copy it, but you could certainly ask a pair of operations that look like malloc a new thing, mem copy old to new, and free, and expect or hope the runtime would turn around behind your back and fold that into a realloc if it was possible.
Does WebAssembly have a JIT that might support that? Because I never heard of that. That would be really that'd be pretty cool.
Certainly their goal to have a JIT. I don't claim they have one. I've certainly had people tell me that this is all going to be JITted by the, you know,
There's
Netscape
multiple
backend runtime, or Mozilla Foundation.
There's multiple levels, right? So you have the top level segment for your whole thing, but within that you can like subdivide and do whatever realloc thingies you want to do within that segment. So I mean, depending on exactly how your application is run, blah, 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 you can get that behavior. If you're just doing it within that segment, you can just do whatever you want with the code.
Because there's no malloc or realloc except what you implement when you go to WebAssembly. You say, give me a slab of memory. You get a giant array and you do whatever the hell you want with it. Yeah.
I had one unrelated question. So how do hardware engineers decide what performance counters to put into their chip? I mean, for the software side, it's pretty, I mean, I have a good mental model for like when a counter makes sense, how expensive it is. You can like, do like core local, thread local, blah, blah, shared, depending on whatever, but hardware, how do you decide?
If it has any cost, they leave it out.
Yeah, if it's going to slow things down. No, at Azul, there were a few counters that went in places that we were highly suspicious of what the hardware was going to actually behave like. So we paid some tiny cost to get counters on like the internal interchip X links and stuff. And I never looked at those counters, and you know, we had bandwidth to spare, but the hardware guys stared hard, made sure the bandwidth was as expected and they weren't getting weird behaviors out of it and stuff.
Yeah, the reason why I ask is it turns out this Apple laptop doesn't actually have counters for like L2 hits and misses, which is like crazy to me because all the Intel ones have that. It only has like L1 misses, hits, like the TLB stuff and like very stall stuff, but it doesn't actually have any counters for whether you hit in the L2 or like hit in the system level count or not, or just kind of like what?
Intel didn't have it for years either.
Yeah.
Because it used
They're pretty
to be,
good about it now.
It used to be the way you test it is you would get the specs for the chip, and then you would run your test and then basically reverse engineer your hits based on that.
Yeah, no, I have cache line size checkers. That Hotspot runs cache line size checkers at startup, just so they could do things like know how much to unroll mem copy and crap like that, how much to prefetch.
I'm wondering if it's like a security issue that you don't want because they have a shared L2 for each of the 4 cores. So you could theoretically learn something if you have those counters. I don't know if that's the reason or if you
You
did.
get timing attacks across
Who knows?
cores.
Who knows? Who knows?
Yeah. I mean, when Hotspot was coming around, it was like the garbage collector is running on a background thread. How much prefetching of random crap should it do? Because that turns in and pollutes the L2, but other hand, it lets the garbage collector run faster background cycles. So we go ask the question, how many outstanding loads can the L2 handle? And you write a little piece of custom code that you guaranteed get so many misses, and you just time it and you decide I can do such L2 cache lines, the ratio of L1 to L2, the associativity, the number of outstanding this and that. These are all things you can get from small pieces of assembly you've carefully crafted. They run at startup and take a fraction of a second. You never know, you never see it, and boom, I have all that data. I think these days you go ask CPU ID, but back when that wasn't going, you did this other hack, and there it is.
One other question is, last time we talked about miss buffers, but one idea I had, I don't know how dumb it is or even feasible, but I thought one thing you could do is in the request that you send to the memory controller, you add some additional metadata that gets sent back to you, like ACK back to you. So that way you don't need to have a structure on your side tracking that information, whatever you would track, it's actually forwarded back. Does that make sense?
Okay.
Who
Yeah,
knows?
no, well, only if you're doing your own custom memory controller, which doesn't make sense. So we had this conversation at Azul, exactly, because we were like ECC, and you just need an extra bit, and then you need 9-bit memory from the DRAM controller companies, and unless you are custom making your own DRAM chips, that ain't happening. And that's, it was too big for Azul at $250 million as a startup to do both silicon for CPUs and silicon for memory.
I think
So
my
no.
question is, like, supposing that you were to do your own, is that idea of like externalizing that state that you would have tracked locally to be replayed back to you so that you can have more outstanding misses? Does that make sense or not? Or
I guess what I'm saying is the cost is prohibitive. Intel makes x86s. It's very hard to compete with them. There's one who kind of sort it. A couple people make DRAM chips. They spend billions of years in maintaining and building new fabs. Competing with them is ludicrous. Okay, I mean, it can't be done. It's just kind of ludicrous. So in a hypothetical, all the world is free, is there another route? Probably. If we could change both sides of that equation, the Intel's memory chip to the memory managed on the other side, is there a better answer? Almost surely. But if you keep them separate, they independently can improve both sides of that equation. And they only have to agree on a spec between them, which periodically they come around, they say it's DDR2, it's DDR3, it's DDR4. And those specs do modest changes that let them be somewhat backwards compatible and somewhat forwards compatible and so on and so forth. But it's very difficult to get these large independent agencies to agree on a mutual totally conflicting change between both sides. We were completely changing how the memory bandwidth communicate, the RAM, DRAM controllers talk to each other.
I think I agree with what you are saying. In my mental model, what I said doesn't actually require any changes like from like the
I heard you
CPU
say,
above.
I'm sending some data through the chip out to the memory controller and getting it back. That's a change on both sides of the chip and the memory controller.
Yes, it's not a change in the DRAM. It's only a change within the
memory
chip.
Yeah, within the memory controllers. Yes.
Yes.
Which go in with every DRAM chip and get wedded and thrown in on top. Yeah. So then you go to both the hardware, just exactly what I'm saying. Go both the hardware guys and say, change your specs. You're making chips that only work with this other CPU. This other CPU making chips that only work with your memory. That's a sort of a non-starter from the start kind of thing. So certainly it's a tall order.
I'm not asking for anything above the memory controller to change. So I would only have to, like, supposing I was the god of Intel and then I didn't care about buffers, I just have to convince the people in my company. I don't have to convince the DRAM manufacturers because I'm not
because you
anything
get
above the memory controller. I'm only
you mean on the CPU side, memory controller?
Yes. This is purely.
Oh, I see what you're trying to do something internal. Well, okay. Yeah, you could do whatever you want. Intel does that all the time. And certainly Azul did.
So the question is that even possible, or does that not play nice with like load store consistency mechanisms? Do you actually need to have something core local to track what you've sent out, or can that be fully externalized and replayed back to you?
You always need a core local to send out. So
So
that your
you
core
need-
can give you, what memory semantics do you want your core to have? So over the years, people have tried various tighter and looser memory model for the hardware in all kinds of ways. And there are certain models that people tried that are just like, can't be coded to. Alpha chips did things where due to cache hits, you could fetch you could fetch from a load through a load without having the first load complete, and then somebody modify it, but you would have fetched the second load. And that out of orderness between those two loads led to a situation which was technically, you could understand it as a memory model. In practice, it was impossible to debug and diagnose. You had a data race that you couldn't figure it out, like load to load loading, load to load cache hitting was not acceptable. So in practice, all hardware says if I load something, I have to get that pointer in my core before I can fetch through that pointer to go get again.
Right.
Okay, so that's, I'm saying that there's limitations to what you can change to the memory model. So now you're asking, can a core give up its knowledge of what it did memory addresses to and hand it off to some other mythical entity? He doesn't talk to memory controller. He talks to his L1 controller, who then talks to his L2, who then talks to his memory controller. So somebody passes this down the food chain. He forgot which loads and stores he had outstanding.
No, sorry. He still tracks, of course, which loads and stores are in flight. So to match up the data once it comes
then
back.
what was the point of handing that information off to the memory controller, which by the way also happens.
Handing off is the miss buffers, not the load store.
I'm sorry, when you say miss buffers, you mean the store buffers? There's no miss.
Certainly the L2 has entries to track what transactions it sent out to memory. And then
that's called the message are missed status handling registers or non-blocking cache.
Right. Can I externalize those or not?
Oh, I don't see why not.
How would you define externalize though?
Instead of tracking the information in the core, I pad or extend the message that I send to the memory controller. And then once the memory controller does that, it passes back to me. So that way I can
my concern would be latency, because people are very aware in computer architecture that MSHR are currently the bottleneck for scaling of multi-core CPUs. However, the moment you move those MSHRs away, note that you are adding latency. And if your added latency exceeds what L2 cache gives you, then you kind of defeat the point of having L2 cache in the first place. So be careful with how much latency this is going to add.
It's not obvious that I would add latency relative to what is happening today.
Everything I heard you say was, I give up some local information. And everything that having to do with latency or correctness has to have the local information to know that I'm not bypassing loads and stores out of order. This is the coherency model.
So the load and store buffers are one thing, the miss status handling registers.
If I have an outstanding cache miss,
right,
and I start doing loads and stores on that line, I can know something about the ordering I have locally. But if I don't know I have them outstanding locally, I don't know what the reordering rules are.
That is true. That is true.
And then I either get them wrong or I stall until I get that miss resolved.
I will need to do some reading. I think maybe it will
Okay.
not work after all.
I've fought this game with the hardware guys at Azul for a while as well to try and sort out what it means. It is very educational and entertaining. But when you're at the hardware level, it's like you're doing physics in a state machine. It's always parallel and concurrent and out of order, and there is no, time is all relative. It is never, there's never a now in this kind of domain. Everyone has their own private now, and it's only ordering as they pass things.
There's no such thing as time. There's only flowing of information.
Yeah. That's a very different model to wrap your head around.
It's the same problem you have in distributed systems.
Yep.
Yeah.
Except distributed systems are super easy compared to hardware design.
It takes a different mindset, that's for sure. It's a very entertaining talk to the hardware guys about, hey, why don't you do this? And they're like, oh, you want an instruction to that? Okay, I'll give you one that does in 3 clocks. You do it this and a this and a this instruction, and it's in 3 clocks. You need it faster than 3 clocks? Prove it. Oh, okay. I can't prove it. I need it faster than 3.
It's
Okay, I'll
funny.
just do the 3 ops and done. But yeah, all the out of order shit was like ridiculously bad.
Yeah,
I would
people who-
say that
People who take the
like
time to
this
get an
with
electrical
Intel.
engineering degree find it rather humorous that we call it computer
Science. Yeah, exactly. They do. Yeah. There ain't no
So-
science in computer science.
I want to get back to hardware counters. So, I was thinking of doing like, sampling-based profiling or whatever it's called, and apparently you need hardware counters for it. And so I was wondering, like, what hardware counters can I assume are present on like a modern system?
You
I
can
guess,
assume
like,
instructions.
So back up. You said I have to have hardware counters for this. Obviously, Hotspot did it without hardware counters in the beginning. So you do not have to have hardware counters.
When you say sampling profiling, what do you mean by that? Because you can use the timer interrupt, as Cliff said, to do
Yep.
like straight up like old school.
There is a very specific random stack sampling behavior you have to watch for that Java in particular steers you wrong on all the time, but other people screw up too. And that's if you're doing a safe point based thing, either for garbage collection or because you just want to have debuggable, optimized code, where there's a bunch of reasons to do safe points. If you only take timer samples at safe points, you lose. So you want a random stack sample. Random stack sample means you take an interrupt on a timer is the usual good way, and you crawl a stack. That means your stack has to be crawlable at every point in time without crashing the VM. For many, many years, like more than a decade, this was not true of core Hotspot. I fixed it at Azul. Hotspot eventually sorted themselves out. Now they no longer crash, but they will throw samples away if they fail to crawl. So it is not a trivial problem to have a stack that is 100% crawlable, but it has to be 100% not crashing at least. And like I said, that was not true for Hotspot for many, many years. In particular, most modern OSs, I would hazard say all of them, cannot give you a remote threads stack pointer and program counter reliably. They have a call that says, give me that thread's current stack pointer and program counter because I'm garbage collecting to crawl a stack. I need to have his stack pointer to crawl it. I need his program counter to look up the stack map associated with that point in the program. Okay, it's a thing you want. And they will give it to you 99.999% of the time, and 0.001% of the time, they'll give you some random crap that is incorrect and you'll crash and burn and die. And this has been true for many, many years. And eventually,
You're
both
not doing the
Azul,
whole selling of the crashing, burning, and dying very well.
well, I had, yes, I don't know. I had miserable experiences here where like Deutsche Bank had crashes that had to be root caused, or they wouldn't pay Sun any more money because their main trading firm went down because of a Java crash. And that turned out to be one of these kinds of things. And the fix was to change how the stack crawl worked and how you made calls out to VM code. You left managed code. The rules on leaving managed code changed ever so slightly. We actually wrote the stack pointer and program counter to thread local storage shared memory place, and they came out in a particular order that was wholly dependent on your hardware memory model. On the clock cycle, they were incorrect if you screwed this up in any way, but the error rate would be very low. But if you did it right, okay, then another thread could read those values and go crawl your stack, and it was all good. So I'm just saying there's a lot of subtleties here, and it's damn tricky. It's the same as the GC thing. You get these little things wrong, you need a new algorithm, you need a core infrastructure change, or you're just wrong.
Yeah, Alan, for like what counters you can expect. I mean, if you're on Intel chips, there's a good webpage from Intel themselves. Only they bothered, probably forced by Google to actually write this down.
What do you get on ARM chips?
So the newer ARM chips, they also have manuals that come along with the things to give you various counters. I thought L2 misses would be normal, but on my laptop, I don't have it. It's crazy. But
yeah, I wanted those. I got them out of Azul, yeah, but I asked for them.
Yeah. Well, for the performance counters, I remember we have used the Intel VTune to analyze the PMU events to see whether the compiled code can cause a branch prediction issue or L1 cache issue. I remember in Intel, there's some people do this kind of work for performance analysis and then send to the compiler team to do the optimizations.
Looks like Theodore's home building today. So he's not there.
Yeah.
All right.
Sorry,
That's, Lynn, I missed the last bit of what you were saying there. If you wanted to repeat that. Just the last 30 seconds.
Yeah.
Yeah.
I mean, well, when I was working in Intel, we used to help finding the performance issue of GT code. We use the VTune which can gather the PMU events from the PMU of the Intel chips. And then we can find VTune is good at mapping the assembly code and the performance events, and which by which you can find whether a bunch of code can cause a heavy loss in the branch prediction, or there is too much cache miss, L1 cache miss, or last level cache miss, and then we see whether we can do some performance optimizations in the compiler. Yeah, there's a lot of such kind of code work.
Yeah, like Matt linked in the chat, the newer CPUs, it's like whatever it's got. Like they also have like stall counters, which is actually what you want to know, like who's actually stalling retirement.
Yeah,
depends on what you bottlenecking on, what other counters you want. The people who've done naive Java generation do the safety checks. They don't do them. I'm trying to remember who is the guilty party here. I want to say LLVM on Julia, but I'm not remember now. Anyhow, the branches are always highly predictable, never fail. So you want them to go to the default prediction direction, which is a forward branch not taken on Intel, which means it doesn't pollute the branch prediction table. But if you have your safety checks everywhere and they're doing backwards branches because you didn't do code layout that way, then the branch predictor, the static predictor fails, it goes in your table floods with a bazillion safety checks, and then your table is overflowed and it's useless, and it no longer does branch prediction in general because everything's a miss in the branch prediction table because it's just overwhelmed.
Sadly, you'll never see that in the small benchmarks when it still all fits.
Yeah, right, exactly. As soon as you get to big code and you've JITted out tons and tons of it, then suddenly, your branch predictor table, your branch prediction goes to and then you're like, why is my branch prediction bad? If you had the counter enabled, why is my branch prediction so bad? The answer is you flooded it. Fine. And that's true of many other little subtle. Intel has all these caches buried in and prefetches and things like that. And if you default, don't touch them or get them right the default way, they'll do for all your places where you're statically wrong or statistically low count wrong. But if you use them by default, they'll work in the small and fail in the large.
I left the room for just a moment, so I might have missed it, but it seems to me that branch misses don't really matter unless you're reading like if you're not chasing pointers, then they do matter. But in Java, you seem to be. I would think that most people chase pointers. So, what does branch prediction usually matter? Because I just
depends on the code.
I wouldn't.
Yeah. I mean, yes, it depends on the code, but if you want it to matter as much as it matters in random C code, then all the well understood safety checks that Java adds have to not pollute the branch prediction tables. If they don't, then those tables are there for all the branches that the user writes that are unpredictable and need a predictor or whatever, not statically knowable by the compiler, need a prediction to go do something with. And if you get your safety checks wrong, then you flood the branch prediction table and they're not available for random junk user tests, which failed now to get predicted.
So is this more for micro benchmarks?
No, it's the other way around. All micro benchmarks have so little code that all the branch prediction tables all work fine. There's enough table space. I write 1 million lines of code. I have safety checks every 10 instructions because it's Java or it's Python being JITted or it's whatever being JITted, JavaScript, all these guys have billion safety checks. If those safety checks go fail the static prediction, and they flood into the branch prediction table. And the branch prediction table's got like what 32K or something, can handle some many thousands of entries. Well, I throw a million entries in, it's completely flooded. Now, if I look up any random missing branch, it almost surely fails to hit in the branch table, and I get a random prediction out. So
Okay,
I
so
predict it correctly.
maybe my numbers are wrong, but from my memory, a missed branch would be like 2 to 5 nanoseconds, and L3 cache is like 10 plus milliseconds.
Don't count it like that,
nanoseconds.
because remember that the branch may be hiding another cache miss after that. So I wouldn't think of branches as something that costs you a specific number of clock cycles or nanoseconds, because it depends on what is the dependency chain that your out of order processor has to serialize behind a missed branch.
Right.
Yeah, that's why you got to look at the stall counters to get the.
Well, if you're hitting L3, if you need 3 different L3 values, that's minimum 30 nanoseconds.
But depending on
No,
whether
that's
it's
a lot of
overlapped
branch
or
misses you
not,
can take.
dependent or not. Then, so.
Yeah, you're missing. The race is on to get your out of order processor to get the next cache miss started in parallel with the last one.
Oh, okay. Yeah.
So there's a theory that says all 3 of these branch cache misses are all going to happen concurrently and take the time for one if I can get them started. So I need to load the first line of this array I've never seen before to go get the array length for the range check. I need to load the kth element because I'm doing a B tree and I picked a random K in the middle of a giant array. Both of those are misses because it's a giant B table, doesn't fit in memory. But if I can run them in parallel, like I can predict the branch will work, so I will now, won't fail the range check, then I'll go ahead and predict and grab the word in question. If I can do them in parallel, I've cut in half my memory latency. And then, later on, they both come back, the branch predicts correctly. Yes, it didn't fail, so I'm allowed to use the word I loaded in the middle of the array, and you're on to the next step. So
okay, that was something that I wanted to ask. So you're just loading both, and then when you get the first one back, you say, okay, the branch is correct, so I can just use the second one.
Yeah,
Right,
and the second one may come back first, and you may take it and run away forward with it, but it's all in the pending to be whatever honored out of order buffer thing. If you then blow the range check, he'll unwind it all. Your cache will be polluted by the range check fail. That is the source of like Spectre and Meltdown security leaks. But in the performance model, predictions are 95, range checks are 99.99% never going to fail. So take it and run. You just, as long as you eventually check it at some point before the program exits, it's all good.
It also comes up in benchmarking parsers for compilers in particular. I have seen people having results where their parser was faster than what memory bandwidth could provide, and that's basically because they were throwing predictable source code with the exact same set of keywords, and the branch predictor has perfectly learned which branches are going to be taken in the parser. So be careful when you are benchmarking parsers or compilers to give them unpredictable input.
Yeah.
That's
interesting. I hadn't heard that, but it makes sense.
For Alan, did he mean something else by when he said sampling profiler, or did we go off on a whole rabbit hole?
Oh, I haven't read the papers carefully, so I have to go back and read them again. But it sounded useful what you said, so I think the links to the stuff will probably be sufficient for what I need to know.
What counters can you rely on? What can you do with them? Some of them are hard to do something with.
A lot of them have like buggy counters. There's a lot of errata on these.
Yeah.
It's crazy.
Yeah.
Because I'm on like a pretty old system, so I know from 2014. So I mean,
you're on Intel or
what?
which
AMD.
AMD?
It's like
Hey,
a weird AMD APU system. So. Oh, Tio. Well.
Sorry, guys. Can you hear me?
You're a bit.
You're oversaturated in sound.
Yeah.
Sorry.
It's like you're going with your. Yeah.
Yeah, your mic's still too high volume or something. It's fine.
Muffled is the word. That's what I'm.
Yeah, we'll sort it out. I mean, it's
Now?
not out of control.
Oh, it's a bit better.
That's good.
A little too little.
Now we can't hear you.
Now,
Yeah, perfect.
okay.
Yeah.
Tudor, you look like you're in Ukraine and you just came in from a,
Yeah.
an artillery barrage or something.
Just a real quick, yeah. So, no, it's just
Is our Russian army surplus uniforms very cheap? I don't mind making a bad joke. Bad joke.
No problem.
Because you run the danger of getting shot at, or what's the?
Yeah, they have a few holes in them, but ignore the blood stains too. But fine.
Yeah.
Yeah, it's just like going downhill fast. I need to stop while I'm behind. I'm getting behind her.
Yeah.
All right.
Yeah.
So Levo, he messaged me that we should talk about this. So I don't know if we'll actually talk about it for a long time, but he said we should discuss functional programming.
Well, we had that talk about type classes that went round, and I got halfway through and I couldn't take it anymore. It was
Well,
an hour and a half.
I had a theory that the reason why you make less mistakes in functional programming is not because everything is immutable. It's because by default, it's immutable.
Isn't that same thing? It's not every, you're right, it's not every, okay, yeah. Well, that
No,
just
you
says that
can-
you're,
You have your arrays, you can mutate them all you want. It's just when you pass them around, they're going to be constants. But you're not forced to have everything constant or immutable.
I would say functional programming is better at decomposing large programs.
yeah, I would
because
say,
the-
yeah.
because
I'm
it
not sure
doesn't
about
have
that
immutable-
because does that actually match your mental model? Because usually that does not match mine. Like pattern matching is pretty good. Like I'll admit
No,
that.
not pattern matching, just the big model, joining together big program parts together. And I guess that's not fair for me to say that. I have only done functional programming projects on the order of 10,000 to 50,000 lines total tops. And I've done much larger C programs, and I don't know how well my FP scales at that range.
Yeah, there are a lot of biases in these measures as well. It reminds me of one of the conferences I was at, unconferences I was at like 20 years ago, and they were telling me about how much small talk was better. And I'm like, yeah, but look at the 20 people who actually learned and used Smalltalk. It's like, these are like 20 of the most brilliant computer scientists in the history of mankind. Like, they could be using COBOL and they would make me look stupid. They could be using BASIC and they would make me look stupid. So like, you give them Smalltalk and they're like, look how good the language is. It's like, well, look how good the people are behind the keyboards, right?
Oh,
Yeah.
I can't. Oh, the camera's got it reversed. It's our.
I can read it.
No,
good.
it's not for us. It's just for you.
Yes, fine. Right. Our little 2.5-year-old overlord.
I
Fine.
think
But
when
I
you
think
design large
FP is a
systems,
lot. I was going to just say like FP is a lot like that. Like, a lot of the people who are like, a lot of the people who are bragging about how good they were at Smalltalk are now bragging about how good they are at FP. And it's like, okay, like, yeah, but show me the million line of code application built with Haskell. Like all the
You're saying there's a self-selection
in
bias.
industry I've seen have been built in C and C++ and Java and C# and Python and JavaScript. Like not one of those nightmares was built in Haskell. It's possible that Haskell is so good that you can't build a nightmare in it, but I'm not sure I'm ready to jump to that conclusion.
It
Haskell
could be the
laziness
case
is-
that the Haskell programmers aren't going to run to the U.S. Army for money to go write a giant ass stupid thing and then have it be a disaster that they don't care about because they're getting paid. Yeah, fine.
A specific aspect of Haskell bothers me, which is the laziness. I don't think it's a good idea. It never should have been done because you completely ruin the cost model. The code. So.
You can route into IDRIS. IDRIS has syntax very similar to Haskell, but it's eager by default. And
I
it's
think Pokemon
actually,
is also eager by default. Yeah.
it's also, in a sense, I would say it's simpler than Haskell because even though it is dependent type system, you don't have to import a gazillion of Haskell language extensions to use it. because it just works out of the box. So that's kind of nice.
According to Reddit, the largest Haskell code base is 1.3 million lines of a trading
Didn't know how the
firms.
Haskell compiler was that big.
All summed up, all Haskell programs summed up, or
No,
I thought a million lines were were GHC.
no. And then GHC is considered the second largest project written in Haskell.
There was some project
Which is not, it's not a million lines. It's at the time of this writing. Oh, it's a very old message. 9 years ago, somebody said they have a 1.3 million line trading program at a trading firm, Haskell, and about 400,000 lines for GHC.
I
don't know how big
Facebook
JC is now.
has some like spam filtering thingy built in Haskell, or I thought I heard about it sometime.
at Facebook. Facebook
Yeah,
it has
Yeah, but that's like tiny. It's
Yeah, how big is that?
Right.
no. I
so
don't-
okay. I found some recent statistics. So GHC, the Haskell compiler, is about 900,000 lines of Haskell code.
Yeah, if I self-host AA, how many lines
But
of code will
most of
AA
those are
be
blank and comment lines.
self-host?
So like it's only 500,000 lines of actual code. So
And I think you have to count comments at that scale because it says something about the ratio of comments necessary to support the code kind of thing.
Also, if you take the succinctness into account, perhaps you would find that a 1,000 line application in Haskell is 1 million line application in Java. Sorry, Cameron.
Mhm. Just
And the
because of
types-
syntax bloat.
Yeah, I totally get it. Like AA, a 5-line code in AA is, 40 lines in Java. Sure, whatever.
Boy, if it's only 40, I bet you only get like an 8-to-1 reduction ratio. I'm going to be. All right, never mind.
But that has a.
But I can
downside
read Java.
too. The program can become so cryptic that you have to get used to it in order to figure out the types, because you don't have to specify the types. That's actually one of the programs, this functional program that has types.
Yeah.
That you can often have to open a large 10-20 files and jump between them in order to trace what is happening, because you don't have the types of your things.
I did that with Elm. It comes a point at which I had to go add annotations in order to understand what types
Yeah.
or to localize error messages.
So a middle ground would be an IDE that automatically fuse them where they should be.
Oh yeah, like the IDE has a quick hot button that just says, I'm going to put the types on the function definition points.
That would be a good feature for.
Ask the language server for the types. And then, user can say, yeah, just autofill in all types on my functions I define.
That would work, and my vision would be the IDE to automatically fill them that like an IntelliJ has a picture that the type is gray, what it should be. So it will fill them, but they should gray that they shouldn't stick in front, they should stay in the background, so to speak. So
Oh, okay.
you still would see them. You still would see them.
Right.
They are filled by the IDE, not by you.
I'd be willing to throw them into the code at some point because it's
Mhm.
documentation.
So yeah, and you can
But
say,
it's a coding style thing.
of course.
But does it still matter? I mean, ChatGPT will make us all go away anyways, right?
If you're going to retire because you're young and ChatGPT will take over your job, that's fine. But I'm not going to retire just because ChatGPT floats around. I look at the things you can get out of it, and the level of assertions I have or trust I have in the resulting code is so low that I feel like I have to basically go write it to know that I've got the bugs out. Like
To
the
be
things that
honest, I haven't tried it for code yet, but we did some tests for getting some initial content for blog posts, and it just doesn't work. The answers that come out of it are plainly wrong. It just comes, if you ask it like Postgres and compression, it just arbitrarily throws every single compression algorithm it finds on the internet and claims Postgres can do that. And I'm like,
right. And it's so confident in its wrongness.
Right, right. To be honest, the confidence and the style of writing is actually pretty good. I'm pretty impressed by that.
Yeah.
It's just that the content itself is completely wrong.
Right.
Not all that different from humans then.
So on
No.
the Discord, someone fed in my code and asked it to explain what my code did, and it was a simple count digits, and it completely understood, even though the guy changed the function name and variable names. Completely understood it. I was very surprised.
I would have
Some
too.
fraction of examples
thought it
will
was
work,
good.
right? It's just a
Yeah,
long
right.
tail of things that break randomly or unknown or whatever.
Yeah, as you get to something larger, then is it going to be faster to debug a ChatGPT, which may have made a fundamental error that caused you to rewrite your data structures to make it work? Or is it just going to, do it yourself? And then if I'm asking a question like, I need to do an API call to go put a fucking window up in Windows that I can draw a diagram in.
Yes,
there's a ton of
documentation.
boilerplate. Yeah, it's a ton of documentation, a ton of boilerplate. Oh, maybe ChatGPT helps. That's cool. Okay, now I want to go do Mandelbrot. That's pretty well understood. Maybe I want to do some more complicated visualization technology. He's going to be completely lost, right? So
I'll believe
miles
it
of
when I can
documentation
hand it-
boilerplate, maybe.
Yeah, when
Other
I can
stuff.
hand it the Linux kernel source code and say find the bugs, and it actually works.
Exactly.
Yeah,
Right.
that'll be the end.
We're not there yet, right? I'm
What I
defining
would
a new
like to
type system with research, aspects of it. I'm combining Hindley-Milner and I'm combining, standard forward flow typing in an optimistic way. And all these terms have strong jargon meanings in the various industries that do. I do not think he ain't doing it, right? It's just not going to happen.
I only did a full text search in SQLite once, so I don't really remember how to do it. Like I would totally use ChatGPT just to like do like a prototype, but I don't dare put any of its code or anyone's code into my actual projects. And also, who wants to read other people's code, even if it came from an AI, versus just writing it themselves? Because I'd rather just write it than try to read someone else's code, understand it, and make sure it's actually correct.
To
See,
be honest, go ahead.
I'd be willing, like if I knew I was just getting a boilerplate question answered out of ChatGPT, this is the name and the syntax and the argument piles for calling the window to throw up a frame, blah, 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 blah. I'd be willing to throw that code in, but I would put a comment that said, I generated this via ChatGPT, but I don't know how to reproduce that code I can't give instructions for reproduction. Here's a wad I got by some magical step. Can I reproduce it? If I can't reproduce it, I don't want that code in the code base, or it has to be treated as if it was human written, because the next person who come along has to do maintenance or change something would start by saying, oh, I'm going to reproduce this by pulling up ChatGPT, who is going to have changed his mind about how to write this code, and it's going to be different the second go around. And this sounds like, how do you get auto-generated code from a AI/chatbot, fuck whatever?
There is also a good question: what kind of licenses of this code? And I don't think this is resolved at the moment.
Oh, that's an issue.
They can put it in
That's an issue.
CPL's code base.
Well, if he finds somebody's code on the interweb and then hands it to you and you include it and that code is copyrighted and you don't include the copyright, are you in trouble?
Pretty sure there's an
Maybe.
ongoing lawsuit. Just
Yeah,
about
I mean, the one thing
yeah.
ChatGPT is getting good at is stripping out the copyright lines from the code it's inspired by.
Right. And then who's to blame? And where does the legal go? And you ask this tool and he says, okay, grep minus strip all copyrights, and here you go, it's clean. And then I'm like, okay, I got this tool from this thing, I'm clean, right? There's a legal issue that's coming around. That's going to hit.
That's why
maybe there was a specific training set to do exactly that.
I still don't want to understand ChatGPT's code or anyone else's, just mine if I can get away with it.
To be honest, one thing that people brought up and that could really be an interesting idea is when you've written something, have ChatGPT look over it and try to do some, kind of static analysis, but from
that'd be neat,
right? That could be cool. Haven't tried that yet, to be honest, though.
I think the static analysis companies, they're already looking into integrating that somehow. Let's see if that works. Who knows?
I was planning to write my own static analysis to suggest slight changes to make the code be more fast or efficient, but I wasn't sure it would be worth the bother because I only had like a few ideas, like a few suggestions in my head.
I think LLVM tried something like that with like assisting you with,
Vectorizer
like, data structures,
guys.
or I thought I heard somebody in some talk say they have some efficiency sanitizer just like they have the address sanitizer. That might be worth looking at if you're interested.
The vectorizer supercomputer crowd has for years asked for and gotten some kind of support about why some loop didn't vectorize. It's 100 times slower. It went from a week to a century. I have to have it vectorized or this problem can't be solved. So why did you not vectorize? I don't understand. And then get those error messages out.
Cow.
After a few more iterations,
Uh,
they just have a pragma SIMD now. It'll vectorize the loop. Period. It may be
Period.
incorrect. And then that's like a separate trade-off. So,
Yeah.
See, when people use Swift in other languages, I just wonder, does it ever tell you if you're doing a copy on write on accident?
Oh, I'm sure
use
not.
Swift.
It's
No.
not on
Yeah,
accident
'cause-
because there's no such definition. You asked
Like I want to
for
say
a-
this loop, I don't want to do any copy,
Yeah,
any copy on
okay.
writes, but I don't think that's going to be supported in any language, which is
No,
one of the
that's
reasons
an
why I wrote my
AA
own.
specifically.
Well, Val supports
Oh,
something
really?
like that. Val supports something like that. You have to explicitly opt into a copy. It will never do copies implicitly.
Oh, right. Yeah, right. Val. There's another one.
Oh, that's pretty neat. I never heard of it.
Yeah, I don't know if the rest of the language is worth something, but you know, I have my notion of fast versus easy, and fast mode won't do copies. But if you do a mutating thing with a fast mode turned on, you'll get an error message of one kind or another saying switch to easy and copy it, or manually copy it, or
Is
stop
that
doing a
compile
mutation.
flag?
That's intended to be a lexically scoped keyword
Nice.
and not implemented. So I'm making up shit as I go. So, you know, big dreams,
Yeah.
getting there slowly. I'm still making forward progress. So maybe.
So do we revisit the type classes? Can somebody do from 10-second snippets what we discussed about type classes? Because that would be.
You're a touch quiet now again, Theodore.
Oh, so.
You posted a video, Cameron, on Typeclasses.
Yeah,
He's asking,
I assume it.
summarize it.
Geez, I've already flushed that cache.
What was the question?
About the type classes.
But
Why-
Alan hated the video, so we should get him to summarize it.
All right, yeah, so I'll summarize the video. So first, okay, so he's like, oh, well, actually, there are like two types of type classes. There's like the real type classes that you find in Haskell and that are great. And then there's like the bad type classes that all these other languages like Scala use that I'm going to call implicit because they don't deserve to be called type classes. Which I disagree with, of course. So
the weak points you mentioned.
Yeah, and so then like, yeah, so he says implicits are bad because they aren't as coherent. And then he's like, oh, but actually, you know, GHC isn't coherent either because it turns out you can put different type class instances in different modules, and if you import them, like it doesn't detect the conflict. So,
I get so annoyed when people say explicit is better than implicit.
Why?
Does anyone have feelings on that, or is it just
the
me?
name is really weird because when he calls implicits, you actually explicitly say which instance you're using, and it gets. I mean, it does usually get implicitly figured out, but you can say explicitly which instance you're using. And in Haskell, you're always implicitly assuming that there's one global instance, and that's the instance you're using. So. So yeah, I don't know. And like the thing I really didn't like was like his diagram of like what was it? It was his argument for why coherence was good. It was like he had this thing that like you have an OR list of A and then you have ord A and eq list of A, and at the bottom there's eq A, I think. I don't know. Maybe I have that backwards. But the idea is
Coherence is good.
well, I mean, so the problem is that, like, you know, just the property that the instances are global isn't actually enough to guarantee that that diagram is coherent. You know, you actually need properties that say, you know, a list is the equality of a list is equality of the elements, equality of let's see, what's the equality of the list, equality of the elements. Equality, you know, ordering of the elements of the list is ordering of the elements, and then you need the last property that ordering is or equality is a special form of ordering.
So I wish Jules were on because we could have a fun conversation, because, you know, I look at all these functional programming languages, I'm like, great, so you have one data structure, list, and you do it almost okay, and then you spend the next 10 years arguing with each other over ordering and equality. Like, is it really that hard?
I mean,
like, no, but we have numbers too. We have the number 0, and then we have the number that's one more than a number, and that's our type system, lists and numbers.
What about -0?
Nope, don't have that. They only have 0 and a number that's one more than some other number, and they don't have lists.
Floats?
They don't have lists. They only have elements. I'm sorry, they only have an element. No, I'm sorry, they only have nil or nil plus an element. Or
They don't support double?
Or list, I don't know.
He's being mostly facetious. Yeah, they usually support double also.
It's
Okay.
reductio ad absurdum to like our
To
language only
ridiculous,
has three things in it,
Yep.
you know.
The one
Anyway.
thing, the other thing, and one more than the one thing.
I mean, some of the things you do need to, I mean, the equality comparison being a notion of order, and then less than comparison being, for example, another notion of order, and then less than or equal being implied from that. That's something that in C++ concept is called subsumption, and it's not that easy to implement, but it is very useful for, well, usability, because if you have a user of container of sortable types or weakly sortable types, you still want this to work with a function that accepts a container of equality comparable types, and you don't want the user to write everything, reinvent the concept hierarchy from the scratch. Well, concept graph, not hierarchy, because it can be a graph, importantly. So that sounds, I haven't watched that video, but that sounds reasonable to me to require something like this.
Right, but I think C++ is a pretty good example where they did eventually get it working, but the result was relatively complex versus what most people would ever accept as a reasonable solution.
Have you read this page you threw the link in the chat on? That supports your claim. It's no more than a few thousand lines of dense text.
Well, but it basically says that if you have A and B, then you also have A. That's it. I mean, that's pretty simple to me, right?
No, it's a wonderful website. I know it well because I've read every page on it at least 7 times. No, I've spent years on cppreference.com. Years. It's a great website.
And how many gray hairs on your head are due to that? I have my own gray hairs.
No,
but, you know.
C++ does not give me gray hairs. Gray hair comes from working at Oracle.
Gotcha. All right, fine. There's some particular hells I have not visited.
No, C++ is ugly, but it's just technical. Like it's like assembly. I don't want to work in assembly, but you just have to put the instructions in the right order and everything works. C++ the same way. Like it's just complicated incarnations, but if you know how to do the incantations, complicated incantations, but once you learn them, they work.
I'm very comfortable in C++, but I still try to get away with doing stuff in C# just because it's so much less code.
You know what I find complicated about C++? CMake.
Debuggers.
CMake.
Oh, yes.
That's the hard part.
Yeah, I don't use build systems. I just use...
You guys are turning my stomach.
Maybe that's the easiest solution to the build system problem. You don't use a build system at all.
Like just about as if I can get away with bash scripts, I use a bash script.
Yeah, I use Windows build and test. It's called BAT.
There's
So
also
what do you
this. There's also this C analysis tool. It basically shows you every single line of C source code that can be vulnerable to security exploit. It's called, it's abbreviated CAT for short.
That one wins.
That's mean.
All right.
So
Me
did
too.
we? I think we got off topic quick on
Yes.
FP.
Yeah.
So Alan,
I-
pick us back up again.
Well, I don't know. I mean, I said everything I saw from the talk. I mean, he had this thing about like reflection of type classes and like, I don't know. I mean, I think, you know, with implicits, obviously, you just already can pass around the dictionary as a value, which I think is the most useful thing. But, you know, I don't know.
And from a Scala point of view, Tudor?
What about Scala?
Well, I mean, a lot of the videos making fun of Scala. So
Yeah.
what's your take?
Implicits are both as someone in the internet said it, implicits trades types for terms or terms for types. I can think of it. They both get useful at some context, but if you abuse them, then it becomes much more tricky to figure out the behavior of a Scala program. If you know how to use them, they're not so magical. But like anything, if you spend understanding the concept up front, that wouldn't be an issue. But to a regular programming that seems complicated, they try to stay away from implicits and type classes and the way they use them.
Is it kind of fair to say that the main difference between OO and FP is kind of like the difference between classes and type classes, which is to say that in OO, we try to solve the expression problem by aggregating everything around a type, and in FP, everything is aggregated around a function.
Each branch has its own tools to solve a problem. OP has its classes, the functional has its type classes and their variants there. It's not necessarily one better than the other.
Also, I wouldn't compare classes and type classes. I mean, they share a similarity, but they are like not comparable concepts in that sense.
Well, there
mean,
are
in-
two
in
different
the-
dimensions altogether, right? Because a class says for a given type, I've got all the methods, and the type class says for a given function, I can cover all the types.
I would compare it to an interface or type class, and I'd compare classes to data, or not sure. It depends on the
Yeah, the
FP
usual-
language. I think it's
usual-
like the you have like this one thing where you actually declare here is some data, and you have this, and that's basically classes or like ADTs or data or whatever. And then you have the separate thing, which is I declare operations, and that's either interfaces or type classes. And I mean, interfaces are basically a closed world. You can't implement interface for some existing type, and type classes are an open world with all the dangers that come with it that people already described. And I think that it's like you can write a compiler or a language saying, okay, I don't even care about coherence or making sure instances line up. I'll just say if people do silly things, the results will be silly. And I think you can go very far with it. The where it really becomes painful and where the coherence question gets really important is if you are some functional programmer that says, hey, I have these 3 type classes, and if I can stack them on top of each other correctly, then cool things happen. And that's the point where you really, really, really have to rely on type classes being coherent. But if you're not trying to do that, yeah, just throwing your hands up in the air and saying, well, if you're defining multiple definitions of the same type class for the same type, then that's your fault. You can get a long way with that, I think. So basically, as long as you are the person reasoning about the code and you're not saying, compiler, I have these 5 type classes, reason about
far
5.
too pragmatic. You sound
do
so
think
reasonable compared to the people online.
Well, we can sound unreasonable, but what's the point in that? The FP has a bad reputation for bragging about advanced concepts that are pretty hard to understand just for the sake of concepts. That slows functional programming adoption.
I still want to ask about implicit versus explicit. Like, what do you guys think about that?
There's a places for both.
Yeah, it's too open-ended a question. Like, implicit what versus explicit?
I think like with many other things, your language has a budget for it. you can decide to spend your implicitness budget on many different things. I mean, in Java, spend some of that implicit budget on converting doubles to integers under the hood, or no, it's the other way, longs to floats under the hood. Yeah, I mean, you can't go overboard. There are like natural limits to how many magic things a normal developer can keep in his head. And if you stay under the line, you can have some implicits, but just not everything, I guess.
Do most people here think there's like a budget?
I
Or
think I would
implicitness.
add to what Simon said, that it's not just a budget, it's also a philosophy, like you want your philosophy of design to be consistent across the scope of the design. So there are some languages like Ruby that seem to get away with literally everything being implicit, like, oh, I put 2 spaces and then a capital letter, so therefore create a database for me. Make sure that the passwords contain at least 4 symbols, 2 numbers. You know, it's like, holy cow, you got that from like, you know, but in Ruby, it just kind of seems to work because everything is so implicit, you know, but other languages, nothing.
You can use the words as analogy. How many things you want to omit and still be understood. So that has to be the balance. If you explicitly say every word and your intent behind it, or you want to leave some words in the context, leave implicit, but still your point, what you're trying to say, is understood. So that's the balance.
I also think that some people mistake implicitness with a way to write short code, and I think conciseness is nice, but it's not like a goal in itself. And I think a better way to achieve conciseness is not implicitness, but having good abstractions. And
I got very little.
Also, level 1 is a challenge.
I should show.
If you want to implement implicit resolution, implicit search, you are looking for a factor of 10 of your speed of completion or reduction.
Well, I know a lot of people have strong feelings about those, but they also have strong feelings about operator overloads and overloading functions. I don't understand why some languages will have one but not the other, and then there's some people that just want none of it. So what do you guys think about overloading functions and operators?
Overloading complicates a language because you don't have one meaning behind a function.
Compiler maybe, but I don't think that.
I would separate overloading from definition. I think allowing the users to define operators for matrices is a very different design choice that allowing users arbitrary ad hoc polymorphism known as function overloading. I think there's a extremely different ends of the scale. If I were to take something from C++ away, that would be function overloading. But one of the top 5 things I would keep would be operator definition, because this is crucial. You need this for anything to do with linear algebra or machine learning.
I like the way you said operator definition instead of overloading. Well done.
Those are exactly different concepts.
So the issue I have is that as soon as I overload my operators, they're just functions. So I've overloaded my functions as well. And now, do I just restrict function overloads to things that have these funny operator names? I got function overloading because I've overloaded my operators.
I have a different issue with operator overloading, which is it sort of similar to what Cliff said a while back. It kind of breaks the cost model when I'm reading the code. If something is more trivial than an I want to see the brackets to indicate the function call. I don't want to have that.
There is that. And I'm going for operator overloading, but I totally am leery of breaking the obvious cost model when looking at code.
I think the problem with function overloading, though, that arbitrary unrestricted function overloading, is that this is ad hoc. You generally don't have any notion of controlling what the overload set is going to be at any particular call site. So this makes it both harder for the code to be analyzed by the compiler, but it also makes it hard to be analyzed by the user.
You can usually figure out from the types, but
so I was looking at big piles of
operator resolution is one of the most complicated parts in the C++ compiler. It's easy to make bugs there, and it interacts back with ADL. At ADL is its own set can of worms.
Right. The key for my head for functional overloading is to make the overloading rules so obvious and so simple that I can tell at a glance which overload I'm actually talking about.
And that supports operator definition, because if you can already precisely express the domain, then you can also express that the operator class is defined on numeric types. And that's not some arbitrary sprawling out of control overloading. You have just a way of defining useful concepts in the language.
And we're already starting from the type classes. This plus is something that can be numeric.
Yeah, and I would not use C++ as a benchmark for design.
Certainly operator plus and C++ can take sort of any two random things.
See,
But
one thing
if
that
you
might
do
actually
matrix.
If I recall correctly, you can't correctly implement operator plus unless you write 4 functions. Correct me if I'm wrong, Matt. Because you have
geez. You mean copy operators and
or plus equals.
And equals. Oh, plus equals.
It's at least 4 functions, yeah.
Really?
You can implement one in terms of another, so maybe it's not that you kind of should actually, in order to have a consistent result. So maybe that's the point.
That's actually where I might have made my mistake. In my language, if you define an operator for plus, it doesn't matter which side of the plus you put the 2 types on. But for minus, minus you can't switch around, because switching it would give you different results. But I'm not sure if that's a mistake, because maybe people would want the left side to mean like left plus right to be different from right plus left.
Actually, so I just spotted something relevant. So one thing that I would say C++ recently did do right is when they added the three-way comparison operator or the spaceship operator, they defined that if you have operator equal and if you have operator not, then automatically you have operator not equal, and that's it. You cannot redefine this inconsistently with those 2 other operators, and that was missing in the previous version, and that was a mistake. So I think you need this consistency, because you will have impossible to follow code otherwise.
So I have a
composing operators, composing functionality. So equals and not equals.
I have a question about operator add as an example. I'm in JavaScript. I add an int and a string. He wants to convert one of them to either a string and give me a concatenated string back, or he converts the other one to an int and gives me an int back. And is there ever a time that you would ever should allow this at all, or you want to say it's always this or that, or only ever mix a string out?
Yeah, you have.
I would say for a scope, you or a scope or an import, or somehow you explicitly know which you want to convert.
Yeah, well, that's what I'm saying. From a look at it, let me go throw some examples in the doc. But I'm
Right.
thinking.
But you have three extremes. You have the C++, well, 4 counting no operators definition, but you have C++, you have JavaScript, you have Julia, which is the multiple dispatch, I think they call it. So
Yeah,
basically the
dispatch.
entire language was built around trying to solve the problem of what Levo was describing with, left versus right around an addition sign, and that ruined the whole language.
Yeah.
Sorry if you're a Julia fan. And then
I think floats are also affected by left versus right, but they're both floats, so it doesn't matter in my case.
I threw an example in docs to see, just to point out. I mean, as the general automatic, I have two things to an operator. Do I auto convert? Do I overload and say the left and the right can be the different types, and I'm going to pick a different operator? I have one that knows it takes a string on the left and an int on the right, or a matrix on the left and a scalar on the right, or a matrix on the right and a scalar on the left, and we all do different things according to whatever. Like, what's the thinking here? Like, we should do automatic, like replace string with a matrix, and I'm doing scalar add into the matrix. I'm doing all elements summed up in a matrix, which makes no sense as an operator. I'm producing a matrix result. I'm producing a scalar result.
My take would be from resolution from left to right. The first argument introduces always as
if it's an int on the first argument, the result is an int.
Mm-hmm.
And then the second argument does what it needs to make an int in the final result.
Or my argument is that both of these should be a compiler error, and we're done.
Yes.
Which is fine too. I'm okay there as well.
Mm-hmm.
But if
Maybe
I can't
just use functions. I mean, just give it a name and be done.
If I do large machine learning programs, which I've totally done, I'm totally with Matt here. Like, having an operator overloaded for a numeric matrix type is fucking helpful.
Yeah, if your users are coming from physics, they will not accept writing function names for operator or matrix operations.
I hired mathematicians to write this code, and they screamed and yelled about not having operators, and I made them not have operators, and they hated me for it.
And
in my language, it would be a compiler error because you're defining the operator plus twice. But for minus or subtract, you'd be able to do it.
I'm adding overload. I'm adding yet another override to the operator plus. How many overloads to operator plus do you want? I'm going to add you a few more, right? Or I'm not allowing operators. I already got operator overloads that said int plus int, float plus float, int plus float, float plus int. So I got 4 overloads on operator plus right now. Oh, I'm doing string concat. That's 5.
Yeah, I'm not sure. That's one thing I'm not sure about. You want to avoid conversions at the same time, because if you are allowing this reach of an overload set definition, you are actually allowing the users to implement their own conversion hierarchy.
Yeah.
And I'm not sure you want to have this in one language construct.
Yeah, I'm trying to avoid having. Personally, I'm asking people's opinion. Personally, I'm against the auto conversion, and I'm saying users implement their own. Now, what does other people think here? Maybe I'm just full of it.
Go did the right thing. You have to manually cast or do the integer cast. There's no like.
Okay. There's no conversion, but there's also no overloading of an operator in Go.
Yes, that is the right decision.
So I can't do matrix plus matrix or matrix multiplication or anything like that in Go. That's.
Well, I actually kind of cheated in mine. I just realized that in my language, if you want to do something like that, you wouldn't build strings by using plus. You would use a quote and then put $ variable name and build your string that way. So this is just so my compiler can figure out the entire length first and then memory copy each part in. So it's just like less work.
Different. As a language design on strings, what I heard you say is I have an auto formatting built into strings, which makes it convenient to convert a number to a string in a context where I want to have, blah, blah. That's fine.
Yes, but this prevents people from using plus. So I wouldn't have that problem in the first place. So I just sidestepped.
Okay, wait.
You seriously underestimate how bad developers can be. You're like your second user will make you pull all your hair out. Trust me.
Yeah, I'm talking about the expert users.
So what I heard you say though is, instead of using string concat as a plus, I demand that stringers always use printf, a formatting string of some kind. And the syntax of a formatting string is convenient.
The pedantic people will follow the standard, I hope.
Yeah, that's the problem with the standard. There's so many to choose from.
Alan, I know you don't want to hear this, but you and Levo may have more in common than you want to admit.
Well, I was explaining this in the Discord, Levo is at the bottom of the evidence hierarchy. Like all he's relying on are like his own.
Yeah, we disagree so often.
Design. I'm at the top of the hierarchy. I've been reading all these papers, looking at their opinions.
I still want to see the papers.
You are both at
like
points of
it,
the pyramid. I'm just not sure if you've rotated it to the right amount yet.
Somewhere the space aliens are warping in on the other corner of the pyramid.
Well, like if you rotate the pyramid, it's like symmetrical, so it'll just like, you rotate.
Which kind of pyramid we talking about?
All I know is that there's nobody in this field that has weak opinions.
Operator overloading is one of those, yeah. People
if it were up to me, I would forbid operator overloading, and the math people they'll just have to write the .add.
I still kind of want to understand why
they can write plus.
Every time I get answers for operator and functional overloading is because somebody's going to do something weird with it, but someone could do something weird with any functions. So it's just like a naming problem.
But you can see it, right? But you can see it easily as the brackets. You have the
Ganesh, though, I think one of your arguments, which is a fine argument, is that it hides a cost problem, right?
Yeah.
But what if you're working in a language like Ruby, where it's going to be 4 hours to do an addition anyway? Who the fuck cares about the cost? Like, it's Ruby, or it's.
I agree with him.
I think the cost problem is more about the developer understanding it, or not how long it takes to run.
Yes,
I mean, developer time is more relevant than.
And I already
CPU.
understand if I'm writing in Ruby that the cost model is both opaque and bad.
Well, I think what Simon said is actually brilliant, because it actually argues both for and against operator definition, because there's going to be a developer that can't read the code if it doesn't have the plus, and there's going to be another developer who can't read the code if it does have a plus, because they're reading it for different reasons.
I think, but then it's arguing against operator overloading, because if you have two options and both of them have like positives and negatives, I say that the solution that is cheaper in terms of language complexity wins, and that's like not having all the fancy operators.
There's such a small fraction of.
Like literally compiler complexity, nobody cares about how complicated your compiler is. You could write like 1 million lines of code in your compiler, and as long as it runs fast, they'll be fine. What they care about is
language complexity. Yeah, right. Language complexity.
Complexity. And telling someone that they can write, 1 plus 2, but they can't write, list 1, 2, 3 plus list 4, 5, 6. Is going to, they're going to say, what? Why not? That's stupid. So there you go.
I agree, it is stupid, but it's also, that's ambiguous, because you don't know if you're adding it like a SIMD add or if you're concatenating the array.
No. If I'm doing list plus list, I know both I'm not getting a SIMD and I don't care about performance, so I don't know or care even what the word SIMD means, as it has no meaning in this context.
Well,
SIMD matters,
There's no reason not to get SIMD. There is no reason not to get SIMD. Why not? You can even use GPU kernel.
That's not the issue. The issue is if I'm using list plus list, SIMD has no meaning to me. If you give it to me, that's great. If it's faster, that's great. I don't know. I don't care. I won't even notice.
You mean not in the cost model implied by the syntax?
Yes, the cost model. Yeah. My cost model for SIMD is at most, there's a big O. It's constant, my big O, so it'll complete before my lifetime. I don't care. Right? Or it's exponential. It won't complete in my lifetime, and I need to change my algorithm. right? That's what I'm saying, that there's a difference here. Whereas if I'm a
It's
a
a one
hardcore
if you count the entire matrix as an element.
right, I'm a hardcore C programmer. I need to know that I can blit this video graphic up on the screen at 60 frames a second or not. Oh, I care about SIMD and I care about the cost model and I care and I care and I care. I'm a mathematician. I'm trying to write gradient boosted machine. I have a very complicated delta encoding of a differential. I want to write my fucking math to how it's readable so I can understand and get it right. And I kind of care about performance and I kind of want to get it right first. And then I'll come back around and say, hey, Mr. C programmer, make this SIMDIs or whatever your magic is to make it go fast. There's a whole different mindset for those two sides of the equation.
And I think the readability argument really is unavoidable. I mean, this is just like if we didn't allow plus for integers. I mean, we are programmers, so we are used to writing things like loops. And for us, it's natural to write something I becomes I plus 2 or whatever. But remember that for people coming from physics, chemistry, it's just as natural for them to write matrix equals matrix multiplied by another matrix. So it's as if you were taking away integer addition from them.
Yeah,
I still don't know what array plus array.
That bad.
And Levo, your
wrote the
question
code.
in the chat is totally on target.
Yeah.
That's what
the
I meant by
question.
SIMD.
That's the question Cliff was asking a while back. But, you know, if it's not obvious to the reader, then you've already made a mistake.
That's exactly why I agree that it is stupid to say you're not allowed to do plus. But for array case, you don't know what it means because I'm pretty sure everyone will have different answers on this. Like
Right.
it'll probably be a 50-50 split.
If I come from a list world, then that's list concatenation, and it's your second answer. And if I come from a physics world, I'm probably doing Saxby, whatever the equivalent for adding
actually
two
think
parallel
that-
arrays.
I think you should define plus as plus to be consistent. So what I mean by that, this is actually this argument with operator definition versus operator overloading. Do you allow some principled set of rules for this definition? And to my argument, you should define plus if you have arithmetic plus in a language. The moment you introduce integers, the moment you have a type with value 1 and value 2, and you define plus to be 1 plus 2 equals 3, then you have to define plus 1, 1, 1, 2, 2, 2 to be equal 3, 3, 3. Otherwise, you are going to have internal inconsistency in the language itself. So the moment you define plus on integers, you don't have a choice. And plus on list of integers has to mean plus of list of integers. I don't think you have a choice if you want to be principled.
Oh, if I have two differently sized integers or matrices and I try to add them,
Type
what
error.
do you think happens?
Type error.
But you don't know.
Well, it's a runtime error then.
Yeah.
Or good enough type system. It doesn't
Okay,
have to be
yeah.
dependent type system. It can be checked easily if you
Yeah.
have something like refinement type system
So
that rejects this.
Just to be clear, Matt, you're still thinking at an assembly level here. Like, you know, you say list, but you don't mean list. You mean an array of a certain size made up of certain size words. And of course, you can have confusion there because you don't really have types. At that point, you don't have types. You just have arrays of bytes, you know, somewhere in, you know, pointers to bytes.
I
somewhere
think
in
he's thinking arrays of ints.
So no, what I'm suggesting is that, you know, in a system with types, like where you have a matrix as a type and a vector as a type, yeah, when you add two vectors and it's 1, 2, 3 and 1, 2, 3, you're going to get 2, 4, 6 because that's what vectors do. Apologies.
I agree with that actually. Yeah, that fully agree.
Apologies to people who use Java that called list vector for some stupid reason.
Yeah,
So,
that's fine.
but vectors and matrices have definitions in math, but a list has a definition in the computer science. And what do you do with a list?
You concatenate when you add them. Yeah.
Concatenate them,
Yeah.
yes. So.
Yeah. And operator overload will work both ways there.
I wouldn't spell it plus though. I mean, there are languages that spell it with double plus. There are languages that spell it with a dot. I don't think there is a reason to choose the surface syntax that uses symbol plus for concatenation. And this is not established in.
Well, wait,
So now
string concat.
I was going to say
String
these-
concat totally does single plus. So many folks do single plus from string concat.
Right.
That's not just Java. That's JavaScript and Python. I bet does it.
But you can see though, once we got into the discussion where we actually understood the types of what we were talking about, the discussion immediately goes to a much more rational point of view, which is, okay, how do we make it readable for the user because we have lists and vectors. Now, how do we make it so they don't get confused when they see the plus sign? So I like Matt's argument, even if I don't necessarily agree with it.
A slightly different take, maybe not widely shared, is that one language can't be expected to be used effectively or well, like ergonomically for all possible use cases. And I don't particularly care about the math use cases. So I would say forbid.
Your life depends on it.
That is true. They can write the .add, it's fine.
Somebody in the universe does
work.
things with math that your life depends on it every day.
That is true. I'm not
So
preventing
yeah,
us from writing
you
the
don't
code,
want to deny them a tool. Somewhere in the world, they need their entire tool chain. I want to put
I think
gas
my
in my
argument
car
is
or
slightly-
electrons in my car. I want these folks to have their necessary tools.
I think we are in agreement. They can use the tools that they want to use. But if I'm creating a new language, I think
Okay,
what I
right.
should do is to not allow anyone to define operators. In fact, I even hate the C#
Okay.
properties because they turn field access into
Into an operator,
which is a
yes, into
terrible-
a function.
So-
Yeah, I don't like
But that's
that one.
why, that's why we don't have field access. We only have properties. So, you know, Ganesh, I'm surprised Alan didn't jump in because he'll very clearly tell you that it's quite possible, because he's done it in his head, to build one language. It's perfect for everyone.
Sir, be nice.
I think you're on mute, Alan.
I mean, I haven't built it yet. I'm still designing things. Like, I don't know. I mean, I know it's possible to make a good JIT compiler, but I don't know if it'll solve all the use cases. So, you know, there's also like, I don't know. I mean, I haven't run into a lot of questions where, like, you know, there isn't like some answer that will satisfy most people. I mean, it's hard to find one that satisfies all people. So, like, you know, I'm aiming for more like 80%, I'd say. You know,
That's pretty sane of you. That's me being sharp now. I'll apologize.
You know, I mean, I wanted 100%, but you know, there's just not enough evidence. You know,
You can't please all the people all the time.
like you know, it's like haters gonna hate, right? Like,
Yeah,
if you could
exactly.
show, I mean, like, if there was enough evidence that I could like literally say to all the people that were like, oh no, I don't like operator load. If I had like a study or something that was like, look at this study, you know, they said that operating is good.
There's certainly a class of people in America today that would tell you to, like, F your study and F you too, and it doesn't matter.
Right. And
Haters
so,
are gonna
like,
hate. That's just it.
want to
yeah, so,
hear about
like,
what
I
the-
mean, and then there's just not enough evidence. So, like, I mean, the haters are probably 10%, and then like the other 10% is just like, I'm going to get some things wrong because I get things wrong. So
I fully expect
Well-
multiple communities just to hate my language so much.
I don't like your keyword choices. There you go.
Oh
What
yeah,
was
I
the
got
about,
I got a lot of those.
all his fields are properties. I didn't quite catch what that meant.
Oh,
Or
geez, I don't like that at all.
Sorry, Ganesh, what was the question?
you said all your you resolve it by only having properties. I didn't
That's
quite
correct.
catch that.
We only have properties. We
What
don't
does
have
that mean?
fields. What do you mean?
Well,
Like,
the
see-
fields are, the state is hidden somewhere, but the access
okay.
to the state, other than somebody who's extremely local, you can correct me if I'm wrong, Cameron, is via a property like thing.
Yeah,
Yeah,
everything's
I
a
have
property.
properties. I have properties in my language. I like it.
And in fact,
Did not, I did
if you
not.
look very
And
closely,
this is-
Ganesh, underneath the property is a property on a different object, which is called a structure. So you can get the structure for the object, and it has properties that contain the values of the properties on the object. And theoretically, if you want to know where those are, you get the structure for the structure, and it's turtles the whole way down.
I think we are living in different worlds, I think.
Well, my goal is fairly simple, which is if you let people touch things, then you can't optimize those things. So I don't let them touch things.
Hey,
maybe
automatic
looking at it from the
memory.
other
I only
side.
give them abstractions. The abstractions have as simple rules as I can come up with that give consistent behavior, and then everything else is left to the runtime to figure out.
Yeah, I
You
don't
can
know.
blame
I
that
think
on
I'm
Cliff.
on the complete
I mean-
opposite side where I think the programmer should have control. You should understand how the structures in your language map easily.
I totally agreed with you in 1970 something. Back when CPUs were only doing a few thousand operations a second. Spot on.
Depends on the company use case, infrastructure, total cost, blah, 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 blah. Right, so yes.
No,
I still use Python, even if it's slow for like some like toy scripts because I don't care. Right, so, but
even though I have my language high leveled, people seem to be very, very angry when I say it's as fast as C, even though it's actually a bit faster. People get so angry just to say it's as good or as fast.
Okay.
I have no understanding why.
I think the point is that 90% of the people who said this before were incorrect. And even if you are correct, you're still basically paying down the damage other people did in the past.
You've made
Nobody's fast as C.
You've made a broad blanket statement. You have not presented evidence. You make a strong statement. You have to present strong evidence. Compile speed, you have to say that, and that removes from the equation execution speed. My compile speed beats C. That's a statement that you can do measuring on, and I can show evidence, and then it makes sense.
So this was the very first time I posted this, it said Boolean is sometimes faster than C.
Yeah.
But then a couple of people in the comment section were saying it's faster than the standard C library, but not C of itself. So I changed the title I changed my page to say Boolean is more optimal than C standard library. So the problem was fread does a copy, and A to int is not inlined, or it could just be improved if you inline it more. But anyway, I wrote the code, I showed the results, and it was like twice as fast. And I'm not expecting it to be twice as fast in most things.
So you've
just
made
that
a
one
jump
case.
from, yeah, right. You've made a jump in your title that all of Boolean beats all of C.
I know, I said sometimes.
Example of one.
I said sometimes. Yeah.
Yeah, okay. So I mean, I've thought this with Java for years upon years. And I was very, very careful about how I said it and why, but that was never, even to this day, I can find haters on the performance of Java. And it's clear from every kind of evidence I can find that on average, on a large sweep of things, they're very close. And I can find specific instances for C beats Java, and I can find specific instances where Java beats C, and the hater's going to hate anyhow. But if you want to make a broad sweeping statement, you have to have a broad sweeping proof to go with it, or you need to be very clear in your title. I have an example where I can beat C's A to F, A to I, F read, whatever, in Boolean, and that's much more believable and no one hate. Then you can begin to expand on that and say, well, here I can do auto memory management in a non-stack pattern, which is very convenient when I have to do hand over hand, arena reuse things or whatever. You can start pulling out examples where you beat the standard model and say just exactly that. But as soon as you say, and X always beats Y, X beats Y without a very strong caveat, everyone's red flag, error goes up. You get flagged as the this guy's full of shit, and now you get to live with that full of shit moniker. And the way out of that pit is to only say in the big bold letters, very specifically, X, I can beat X and Y in this situation. And then it's hard to disprove, and it's enough evidence that I can go see that it could be true. I can go prove it myself if I want to. Then I can believe you. Okay, that's not shit.
I thought
that's
sometimes
it's only two more words to say faster
that's a long
to run
title.
or faster to compile. I would suggest just adding.
Yeah,
those
if it's
two.
faster to
no,
compile,
this wasn't compile. This wasn't
yeah.
compile time. This was actually
right.
This is doing some work, and it's twice as fast. But I didn't say it's twice as fast. I said sometimes it's faster, and I showed an example, and I explained how to get the speed in C.
I said in the
but
title,
I didn't want a long ass title. Like,
yeah, in the title, say I can beat fread in certain circumstances, and people might believe that. If I'm going to say I can beat C, which is also true because C, fread's a part of C, then that's a much broader
fread
statement.
was only half of it.
I don't care which pieces you're beating. That's obvious that they could be. I can always pinpoint somebody's standard library. Use a standard library for C. Well, which standard library? The one that was used by Azul, where we did all kinds of optimizations in GCC? Probably not. Did you mean the standard library that came out of some Intel project, or did you mean the one that comes shipped with Red Hat or with Debian or whatever? That's already, I'm talking about all standard libraries, including ones that, you know, me as a Linux kernel hacker have handwritten that I know you fucking didn't beat, right? So you're still putting a lot of broadness on those statements, of which some of them are clearly not correct for some people. And that's your problem. You want to play the speed wars, you got to be very careful.
I think the problem was I didn't want a long title.
Yeah, well, then you can still refine the title and keep it short.
I mean, you could write many articles. You could pick one aspect where you are faster than C and write a short title about this specific aspect you're faster than C. And the big benefit of that is you can not only write one article, but you can write as many articles as you have evidence. And I think if you have this broad selection of articles where you show individual cases where you beat C, it will be much more credible than having one article that needs to have a big asterisk at the title.
If you are going to write the articles, I would suggest analyzing both sides to see exactly why it is faster or not.
I definitely should get you guys to read it because I explained
throw the
exactly
link
how to
in.
reproduce the answer in C, and it's just a lot more C code of like how to do it. But yeah, I was very
Yeah, it says,
careful.
so
But
more
people seem to be
optimal
mad.
standard library is both correct and way too broad if you're optimizing a single tiny fraction of a very, very, very large standard library, right? And here's a quick read. I'm looking at the link you just threw in the chat, which should go in the Google Docs. And you're going to put some timing numbers and so on and so forth. And what you're really coming around to is somebody's not gotten the inlining of A to F, or it should have been compiled differently, or they picked the wrong buffer size or whatever. There's something going on here that we could argue our way forward as to why one is faster than the other. But the title might instead say more optimal A to I, or more optimal F read than the defaults. Like everyone knows the defaults for buffer sizes for standard libraries are they're well chosen to be generically optimal in many situations, and there are totally places where they're the wrong size. Anyone who looked at the Google file system, for instance, will happily tell you, yeah, Google file system standard file size 4 gigs. That's the, the buffer is like fast and huge, and they got a giant speed up out of that, and it's totally makes sense for Google file system. So
basically saying inlining more helps being faster or something.
Yeah. And if you have a small micro benchmark and you fail to inline something, you lose. You must inline everything in these small benchmarks.
Well, it was two things. One was the inline, but the other thing that the C standard library probably would just never do is change fread to actually give you a pointer to the internal buffer, because that's what I did. I just gave the code pointer to the internal buffer.
Why you would say that? Me in the land of optimizing compilers, back in the day when I was really doing C compilers, I knew what the hell fread was. I could inline the source to fread into your code, which would just expose all those internal pointers in the buffering. And that was in fact an
Well, that's what they did.
No, that was with a link time compiler. You compile to a .o, he compiled to a .o, I got a library, you got a library, blah, 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 blah. You hit the dash link time compile or dash link time optimize. The compiler kicked in.
I wonder why this is so slow.
And I don't know that you did it or you asked for it, but I had that technology working at Motorola 30 years ago. And that was a common flag to throw if you were doing benchmarks.
You can try use strace on this to see what system calls are being made. That would be a first step.
That would be another, no, I'll say first step. That's a good step though. For instance, if your buffering is too small, you're calling strace, you're calling, file read 1 billion times a second instead of 1 million. Yeah. All right.
I think if you do enough of this, you will see that there's no intrinsic reason why C can't be as fast as you can write.
And the title looks like
inline assembly and so on.
Yeah, the title looks like it's actually impossible for C to be fast here, and that is just not true. So that's the misreading I'm getting out of the quickie read in the title.
Standard and PostX libraries are a bit different. But
Yeah, I don't know what your flag is. Link time optimization there. I don't know what that one does. I certainly had a flag at Motorola's compiler that was inline the source code at link time, specifically to cross library boundaries. That was the point of it.
It's also something like beating the market. You know, you can beat the market, but over time, you know, can you beat the market consistently? And the same thing is true when you're trying to beat C or C++. You're up against, you know, 100,000 people working for 40 years, 50 years.
Yeah,
And
and
there's no
continuously working
intrinsic
today.
reason why it can't be fast with sufficient engineering, right? So that is, I think, one other missing understanding
Well,
piece.
and a lot of this engineering's been done, and you may not have it in front of you, but people have known about it forever today. It's all good.
I wonder
You've
when,
done some cool stuff with Bolin, so
yeah, I
mean, I
wonder
think
when Clang is going to implement Sieve nodes.
I'm not gonna hold my breath. I pushed on that, got
Yeah.
pushed uphill for a while, and then I was like, you know what? I got things to do with my life. People don't want to listen, they're not going to, and there's no point in yelling if they're not listening.
I'm positive it's going to be a long time before any compiler even gets like 1 million lines per second. Like
That's compile
one
speed.
that doesn't, yeah, one doesn't, I mean, TCC does it. I think TCC does 8 million, but it also requires headers and specific order. So I'm talking about like no headers.
One question to Cliff, going back to the sea of nodes. You remember the program dependence graph, right, Cliff?
Yeah.
So
right.
someone has done this for an LVM. It's called Noel, and it actually simplified loop optimizations for like, you go from several screens of code to optimize a loop to something that fits on one screen and can deliver better performance. So that's interesting, I think.
Okay.
This Noel project, I posted this in.
Right. I was reading the top level page. I haven't yet got to the point where it says something about how it's program dependence graph internally, but yeah. Or
There's a paper they
does.
released. They just released this year at CGO conference.
Yeah.
I
Okay.
can post the paper as well. So it's actually pretty impressive, I have to say, what they achieved.
Yeah.
Okay.
I posted a link to a VLang review as well, which is kind of
Yes, saw that. That was fun and painful. Wow. I don't want to get one of those written about me.
yes, exactly. That is actually why I posted.
This is a major claim of this language. Let's write a one-line, really short program and verify this major claim by the language. Oh, it didn't verify. Okay, wait.
So Levo, those are the ones you want to avoid.
So anyone which is claiming fast compilation times, it has to take into account the features it's compiling. So it's very difficult to compare language to language in order to verify speed.
Yeah,
so
compile
features,
speed. Yeah.
So
yeah.
If you
the Scala guys are not doing compile speed tests with anybody.
So that's the point.
But but exactly the point of Scala is not about compile speed. It's about.
I don't think there's even any language comparison suite that everyone likes. I mean, I remember there's this language shootout benchmark that everyone complains about, and it's mostly known by people complaining about it. But I don't know of anyone proposing even a better alternative either. So it just looks hard.
So how should I say? One point you could compare languages that they both implement some functionality that is accessible to both language. So you can say this in my language is speed X, this in my language is speed Y.
I don't have first-class functions, so I can't compile anything with first-class functions. Now,
so
what do I get out of it if I, what do I get out of it?
Feature has to be comparable. Features have to be
comparable. This is funny stuff though. Like, well, maybe there's a thing where like, okay, I can recode this lambda for loop with a inline, thing, and it's obviously easier to optimize. So the C version works really great. But gosh, the Haskell version, which just took the function as an argument over the iterator, was so much easier to read and quicker to write. And, you know, and, but I can write the Haskell version and the C version and it'll run fast as well. And, you know, what's the shootout mean then?
We have to consider effort. So
yeah, there's an effort. Yeah, right. Okay. Okay, wait. We are over time. And we've had a good conversation, and there's always room for more.
Yeah.
But I want to go play with my granddaughter and give grandma a break.
Yeah.
And I'll get the video from Cameron. Thank you, Cameron. And so probably a little long before I get back home and get it uploaded onto YouTube. So this one will be a little while before it shows up. All right. Till next week, till we meet again.
Yeah, see y'all.
Bye, guys.
Bye-bye.
Bye.
Bye.